All right, so let's get started. I'll do a little bit of introduction about myself and our company. My name is Maran in short. My full name is Marudhamaran Gunasekaran. I'm a principal security consultant with Practical DevSecOps. We're currently engaged in training and consulting business. That means anything that has to do with application security, product security, DevSecOps, AI security. We create training programs, certification programs for real-world engineers like you and me. And we also consult organizations, implement the things that we learned here in consulting and consulting back into our training programs to keep it real. What we're going to do today is we're going to complete 3 lab exercises with respect to AI security. This is the Sublime editor, and this is going to be my whiteboard for today. I'm going to be typing as I talk, explain some commands or instructions, or talk about some architectures. So I'm going to use this editor to do that. Once you're logged into today's portal, this is the environment that you will see, mini API security workshop. And if you scroll down a bit, right, if you scroll down a bit, there are about 8 hands-on exercises, right? There's introduction to AI security. The first 2 are just introduction to how could you use Practical DevSecOps labs. You could skip that altogether. But today, we can only perform 3 activities together in this session. And you're also going to have some lab access, some level of access to the system for the next 2 to 3 days. And you could practice them in the next 2 or 3 days as well. So the labs that we're going to do today, we're going to start with talking to an API using OAuth and JWT, right? So that's the first simple lab exercise that we're going to start with. And here, talking to an API. And before we do this, could someone tell me the different, oh, yeah, we have chat. Let's use chat. Could someone tell me the different types of API architectures that you are aware of? Let's say you have a team and that team is telling you that they're building an API. What are the different API architecture styles that you've heard of? Okay, REST, SOAP, good. What else? Okay, REST, SOAP. All right. Anything else? Fast API, okay. GraphQL and GR, okay, REST, SOAP, GraphQL, gRPC, all good answers in one line. Very good answer, Zane, okay. gRPC, okay. What else? Others? REST, SOAP, GraphQL, gRPC. Great, so those are different architecture styles. SOAP was the first evolution of API, then came REST, then came GraphQL and gRPC. Today, we're only going to be talking about REST APIs. So REST APIs is the only APIs that we'll be dealing with in the mini API security workshop. Could you also type in the different authentication and authorization mechanisms that you are aware of, all right, when it comes to securing these APIs? JWT is one, okay. Token-based, API key, OAuth, API key-based, single sign-on, basic auth, JWT, OAuth, okay. What else? What else? Authentication and authorization. Cookies, session-based, okay, all valid, okay, all right. Anyone else? Anything else? Authentication and authorization mechanisms are widely used in today's APIs. OIDC, that's what I was expecting. OIDC, OpenID Connect, particularly supposed to be used only for authenticating API endpoints, OpenID Connect. Okay, OIDC, good. Okay, great. So let's gather these things together. So we've got API architectures, right? We'll start with SOAP, and then we got REST, and then we got GraphQL, and then I'll stop at gRPC. Okay, and then with authentication and authorization, I'll capture everything that you guys mentioned, JWT, OAuth, and then OpenID Connect, and then get session-based, you mentioned cookie-based, and someone also mentioned token-based. What else? Session-based, token-based, someone mentioned SSO. Basic auth, definitely, yeah, basic auth. And you've got API key. You've got API key. And what else? There's one more thing. Yeah, token-based in general, right? Tokens. I'm just going to subgroup them in token-based. I'm going to use JWT there. And then there's also another token called MAC token. So I'm going to kick off JWT from that list. And then OpenID Connect, I'm going to abbreviate this to OIDC. Session-based and cookie-based, I'm going to put them together. If we talk about REST-based APIs, you're going to probably manage your session using cookies, or sometimes in a browser using other things like local storage or session storage options that are available in browser. Those are also used in some scenarios. SSO basic auth API keys. I'll move down SSO a little bit down and keep API key down there. We can also further split these two things into what is authorization and what is authentication to get a clear nomenclature or taxonomy of what do we mean by authentication and authorization, but we'll do that some other time. The first lab activity that we're going to do today is very, very simple. We're going to be using CLI tools, and that would call Rust using JWT tokens, right? So we're going to have an application here. I'm going to share my screen. SSH. Okay, are we supposed to see your screen? Not yet, not yet. I'm not sharing the screen yet. So let me share my screen here. Yes, you were supposed to see your screen. Sorry about that. So this is what I was typing, right? So what we're going to look at is a simple lab activity of just trying to call an API with command line tools and explore a sample application. So I'm going to do a demonstration of this first. Give me 5 to 10 minutes, and then we'll spend about 10 minutes independently to do this exercise together. So this is our lab platform. You could start the exercise. You see when I started, it gave me some error message. I can refresh my browser window and I can say start the exercise, and this is supposed to start the exercise for me. Not sure why this is the case. Let me refresh again. This is supposed to work. Or there are some other options that we could try. If this does not work, let me wait for this connection to succeed. And if you want to look at what are the steps that are present in this exercise, you could use this particular option here, go navigate. Otherwise, we'll have to go next, next, next. There are also a bunch of resources that are available for you here. The first one is the terminal, which is what I'm waiting to be connected to. There's also another machine here. Okay, I tried 3 times. It didn't work. What I'm going to do is I'm going to refresh my browser window again. I'll do this using the option here. And I will reset my environment, which is going to completely provision a new environment for me. And I hope that would work well and help me proceed with this demonstration. And if some of you face the same error message, refresh your browser and then say reset your environment. So that did it. So here we have the terminal is here, and I can do things if config or anything that you would want to do in a standard Linux box. So this is the terminal. And we'll have to wait for this little machine to get provisioned, because that's the machine that's going to contain the API that we're going to be calling using the command line tools. Okay, so that machine is up. The web server is getting started. Should also be up momentarily. In the meantime, okay, so those are up. If you type curl in here, you should have curl already installed. So let's go to the next screen. Yeah, so OAuth is used for authorization, relation between OAuth and JWT, right? So OAuth is an authorization protocol, and JWT is a specific type of token. If you go read the standard draft for OAuth 2.0, they kind of allude, because it's a framework, they're pretty open to different token types. In the spec itself, they describe two types of tokens. One of them is JWT, and another one is MAC tokens. Though the usage of MAC tokens is not prevalent, it's still used in different places. But the most predominant type of tokens that are used on an everyday application is JWT. So JWT is a specific type of token. It has a certain structure, and there are different types of OAuth flows as well. For example, when you're authenticating your Netflix account to your television, there's a specific OAuth authorization flow for it. If you are authorizing a third-party application to gather information on your behalf, there's a different OAuth flow for it. There are different OAuth flows. And then there's the JWT token that we will use, right? JWT token itself is split into three different, it has three different things. It has this specific format, a header, a payload, and a signature, which we will see. And yeah, so this is the format. There's a header followed by a period, and there's a payload, and then there's a signature, right? So the instructions here are, we'll have to open this application, right? I'm going to click that, and it's going to open this for me. Okay, hold on 1 minute. This is supposed to work. Log in, or maybe I'll click this. Log in, or hold on. Let me check this. Step 2, get to the developer tools. Could you guys try this and see if this works for you? Log in. Let me probably try another browser. This could also be a thing with my browser window. Okay, so that is a thing with my browser. That's a thing with my browser. I have some problems with Firefox lately. So here is the application. All right, give me 1 moment. Works. Okay, thank you for the acknowledgement. And right, so here, what are we saying? Open the browser's developer network tab and choose the preserve logs option. So we're going to grab the JWT token that's going to be used in the scenario. So I'm going to right click, inspect element, go to the networks tab, and where's the preserve log option? It's already checked in. And I'm going to enter credentials here. The credentials that I have to enter here are presented. User1 at CASP. And the password is user1 password. When I click, it gets copied. So I log in. And I'm logged in. I'm logged in here. There are a bunch of things. I can get details. There's some product details here, and I can get reviews. So very basic application with minimal functionality. But what I want to do is go and grab that login request where I sent my user ID and password. So that's the user ID and password that I sent. Here is the response. failed to load the response because this content was redirected. Okay, great. Let me check cookies, see if there are cookies that have been sent here. There seems to be some cookies here. And there is an access token, right? There's an access token here. And there's a value. This is the value of this access token. Different browsers is going to present you with a little different user interface. This is Opera that I have it open. You may have a better view in Firefox or Chrome. So let me copy this value here, right? Let me copy this value and get to my whiteboard. This is the value of the access token that I grabbed that this application is using. And as you see, it's separated by these 3 dots. That's the first dot. And that's the second dot. And here is the third dot here. So first one is the header. The second one is a payload. And the third one is the signature to maintain the integrity of the token, right? Now, there are a couple of ways that we could decode this. I don't want to worry about the header too much at this point. I'm going to take this payload value, right? I'm going to take this payload value and I'm going to use this base64-d option, Linux, the standard command line utility here, to decode this value for me, right? So right there, it tells me that the user ID is 1, name of the user is Bob user 1, and that is the user. There's a role for the user, which is a user. Maybe there's an administrator role as well. And there are also values like this token expires at this particular time. It's issued at this particular time. It should not be used before this particular time. We also have an error from base64 that this is an invalid input, and that's because the encoding of this particular the encoding of JOT token is not base64, but it's base64 URL, which is a slightly different form of URL encoding. So what we're going to do in this particular lab exercise is to learn some command line way of grabbing the same thing. So it's going to help us do our assessments better. Okay. So what did we do when we went to this application here? We went to the application, put in our user ID and password, and then grabbed the cookies, right? That's what we did. And that's what we're going to do programmatically here, or a little bit of scripting. So first, there's an API endpoint called reviews. How do we know this? Because when we looked at this, so that is the, where is this? So this is the products. And when I click this reviews, so there's number 4, and I'm going to click this. There's number 3. So there's an endpoint called reviews, and that's how we know that exists. So we're going to call this reviews endpoint, and we get a response. This means that reviews data are supposed to be public. That's what it means. Let's try and call the products endpoint using the command line utility curl. And we get an error message that this is forbidden. I don't have permissions to call this particular resource, right? So what we're going to do is we're going to grab the environment variable. So this is a pretty long command here. And if I don't know what this command does, there's a little explain this to me feature that I can use to obtain a GPT-based explanation of what this command actually does, right? So, in this command, login and save, right? We're calling the login, and we're putting in the user ID and password, right? And we're saving the headers, response headers, to a particular file. Why are we saving the response headers? Because you see here that the access token that we grabbed is a part of the response header. It's not a part of the response body or anything. So that's why we're doing that. And finally, yeah, so we take the access token. Sorry, one moment. Let me go copy paste these things. Okay, so there's a response header. And then from that response header, we grab the access token. And finally, store it to an environment variable. So this is the access token that we have, right? So what we did before is we called the products endpoint, right? We called the reused endpoint, which was public. When we call the products endpoint, we had a problem with authorization. And now we're not going to have a problem with authorization because we're sending the authorization header, which means we want to authorize to this API endpoint. We still want to use the HTTP GET method, and we want to call the products endpoint with the authorization token. So when I go ahead and do this, then I should get a list of products. And that's a small show of how we're going to be calling APIs, grabbing their access tokens and other things. So this particular lab is the first warm-up lab that we will try. And I'm going to paste this in Zoom here. There's Zoom. That's the link. I'll also start a 10-minute timer. Let's go ahead and complete this lab in 10 minutes. If you have questions, put them in the chat and I'll answer them here. First warm up done. Okay, thank you. No problem. Dan, what we're going to look at now is when we went and discovered these little API endpoints in this lab. There are some API endpoints that we discovered. So let me close this and let me clear this too. And I'll do this from the beginning to keep things a little bit clean. So I click details. I have a product endpoint here, right? So this is the products endpoint. How do I know? If I look at the headers, that takes me to products. And I get reviews, and that takes me to API reviews by product /1. And let me go to your coupons. It seems that there's a coupons endpoint as well. And let me get register my device. So that also takes me to an endpoint that's register my device. And there's an option for favorites. Takes me there. So what we're doing now is we're discovering API endpoints. And let me clear this and go poke further into these endpoints. It says add current products as favorites. So that takes to API /favorites / an option called save. And it also gives an option in the UI that says favorites saved. When I go retrieve current favorites, it gives me some options here. But when I go hit retrieve, it also goes through API /favorites, but it brings me to an option here called retrieve. Now I'm going to take this as an example, right? And talk a little bit about the REST structure. So that's save. One of them was the endpoint called save. The other one was the endpoint called retrieve. And I'll try and grab one more option, access logs. Now I'll try and grab products maybe. Okay, I don't want to add products. Let me try and grab save my device, see if that gets anything. Nope, home. Okay. And I'll go pick up details. I'll pick this guy here. I'll grab his URL as well. So with respect to the REST architecture here, API is going to be something that's pretty standard that you're going to see. So this option here, after the host name, right? After the fully qualified domain name, API is something that you would often see. What follows next is often referred to as the object itself. So that's kind of the object that we want to poke around. We either want to create objects, retrieve objects, delete objects, or update objects, right? And products is also an example of objects. The number one you see is a particular identifier. So what we're saying essentially here is I want to get, I'm not specifying. So let's imagine this is a get operation. I'm saying get products with the particular identifier of number one. But what we're doing here is on the favorites object, right? On the favorites object here, on the favorites object, we either want to perform the operation of save, or we either want to perform the operation of retrieve. So we're going to call favorites as the object, products as the object, number one as the identifier, and these little verbs, we're going to call them as actions, right? In English, they're actions, and anything that's an action grammatically is called a verb. But then in the language of HTTP, we also have different verbs called get, put, post, delete, patch, options, and so many other verbs. So these are verbs, right? These are verbs in HTTP. But since REST protocol uses HTTP behind the scenes, these verbs still apply. But these API actions that you see, they're also referred to as verbs in terms of API architecture and security. So there can be authorization problems in any places. There can be authorization problems with the identifier. There can be authorization problems with the operation that you want to perform on an object using these actions, or also using these HTTP verbs, right? The reason we talk about this now is we're going to identify hidden endpoints from an API. Now, there are easy ways to do this. I can open this in a new tab, and I can quickly try and poke around things like API underscore docs. Not sure if that exists. See, that's forbidden. Maybe it's API docs, or maybe it's just API docs. Oh, that worked. That's loading up a Swagger UI here. So this is a way that I can gather further endpoints. So there's API products and other things. There's also coupons and other things. But using this particular lab activity here, let me start this lab. Using that particular lab activity, we're going to use a fuzzing tool called FFUF. This is a command line based, insanely fast fuzzing tool. And this tool has capabilities of parallel fuzzings using GPUs, fuzzing multiple endpoints and other things. We're going to see this in action. The goal of this particular lab is we're going to identify hidden endpoints. So we've already identified these endpoints here, right? Some of them. These endpoints here, favorites, products. And then we also browse through the API docs. We also have these other paths / endpoints that we have identified. And I want to use the FF tool and then see if we're able to identify further endpoints. Okay, so first step is installing the tool itself. So some copy paste of command, I can click and then paste them. I can click and then extract it, get inside the directory of the FF executable, and check out its options here. So it's got plenty of options. It's got plenty of options here. We're going to be using the option of, so just like curl, if we want to send the get parameter, we will use the -x option in curl to say, I want to perform a get operation or a post operation. You will kind of follow the same thing in FFUF as well. Same thing with headers. In curl, if you want to set headers, you'll use the -h. In curl, if you want to set data, you will use -d. So some auctions are kept pretty relevant and comparable in FFUF when you compare it to curl. So that's FFUF. We have installed FFUF here. And what we're going to do next is these are some endpoints that we have already identified. Again, how did we identify these endpoints? We identified these endpoints by looking at the API docs, by browsing through the applications, and other things. So what we're going to do now is we're going to, we've already explained, we've looked at these parameters and see what they do. So we're going to create a list of words, right? Maybe there's an endpoint called payments that's hidden in the API docs that's not actively used by the application, but maybe it exists. Maybe there's something called customers. Maybe there's something called devices. Maybe there's V1, V2. So this is a guess that we're making. This is the brute force attack that we're going to do, but it's kind of controlled brute force with about 25 words. So that's what we're going to do. And then once we have these list of words that are present in this file called word list, right? Our list of words is presented in a file called word list. And then what I'm going to do is I'm going to call FF, supply this word list, and I'm going to tell FF to use the list of words after API. So what this is going to do is if I go back to my Sublime editor here, so it's going to take this URL and it's going to replace the word fuzz with things like payments. It's going to replace the word fuzz with things like invoices. And if I grab my list of words, cat word list, it's going to replace this with devices. It's going to replace this with customers. Okay, and it's going to replace this with V1, V2, and so on and so forth until the entire list is complete. So that's what we're going to do. Let me fire this operation and see what happens. Okay, so we get some results, and let's slowly go through these results. See, everything results in a 403. Invoices, orders, downloads, everything is a 403. I do not see another response. I don't see another response. Now, 403 status code could mean many things. 403 could mean that there's the endpoint that's available, but it needs authorization. 403 could also mean in some other situations that it's a very generic error message that the API developer chose to respond with. We don't know. So in order for us to compare this, we will have to use how an existing endpoint responds to us, right? So we know that there's an endpoint called reviews. We know that there's an endpoint called products. And we know that they're not endpoints, they're objects, if I have to stick to the terminology. So these are objects. So there's coupons here, there's coupons, there's products here, and there's products, and there are also reviews here. So what we're going to do is create this word list called available resources, right? Available resources. And I'm going to try and fuzz with the available resources and then see what kind of responses that we get. Okay, so we know that reviews exists, but it responds with a status code of 200. We know that coupons exist, but it responds with a status code of 403, and products also responds with a 403, right? And the reason these two respond to the 403 is because they require authorization. And the reason this guy responds with a 200 is because it's a publicly available endpoint. Remember, in the previous lab, when we called reviews/1, we did not require any authorization. The API just responded with a list of reviews. But products required you to send an access token. And that's why this response is. So we're a little bit confused now. So the APIs that exist, the endpoints that exist, they're also sending a 403. And the API endpoints that do not exist, they're also sending a 403. So these are situations you might encounter in real world applications as well, right? And there's no standard way of doing this. Of course, there are conventions, but different applications, different developers, different architects, they try and choose error messages in a different way possible. Okay, so with this information, I want to go and download another list of words from GitHub, and I'll show these list of words, right? There's going to be a huge list of words. It's probably about a few hundreds, maybe, right? I'm going to use this list of words, and I'm going to I'm going to send FF, but this time my FF command is different, right? Take a look at this. Fuzzing objects and fuzzing actions. So let me grab this URL here. Let me grab the URL from the command that I'm sending to FF, right? So this is what I'm sending to FFUF. So what I'm going to do is I'm going to fuzz objects and I'm going to fuzz actions as well. Okay, so what this means is when I had a single fuzzing point here, everything in my word list got replaced at that single point. And now I'm fuzzing multiple points now. And with two different word lists. Okay, so the previous word list is going to be payments. So if I have to play this is going to be payments. Sorry, this is going to be payments from our first list of words. And then the second list of actions, right? If I look at actions, that's going to be a lot of text in there. And this is going to be accelerate, right? It's going to be accelerate. And then again, the first word is going to be payment, and it's going to be accelerate in lowercase, right? And then the third word is going to be acquire, and it's going to go on and on and on, acquire, right? ACQUIRE. So this is going to go on and on until this entire list is complete. So we're fuzzing two operations. And then after this is done, we're going to pick up the next list of words, which is customers from the word list. And that's essentially what we're trying to do here. So fuzzing multiple endpoints. Let's see how this goes. This is going to take about a minute or two roughly, right? So we're sending approximately 6,500 requests. What are we doing next? Are we also filtering the results, saving the results to a file in this command here? Yes, so we're also filtering the results to a TXT file. And what we will do afterwards is we'll look at response codes that are not 403, okay? So we're interested in looking at response codes that are not 403. And as you see here, or sometimes the word generate, gen, and then we're replacing all the other words here. So we're halfway through, and we'll have to wait. And what we'll do next is we will read the output.txt. So this is the command that we sent. This is the command that's executing now. Okay, this is the command that's executing now. The output of the command is saved to output. So we're going to read that output file. And this is in JSON format. So we'll send it to this command line tool called JQ. And then we will filter the response code that is not equal to 403. And maybe we'll get something that's a 200, or maybe we'll get something that's a 404, or maybe we'll stumble upon another error code that may be worth poking into. Okay, so the operation is complete. And when I filter my fuzzing results, and when I look for status code that's not equal to 403, I get a status code that's 405 here. And I also get a status code that's 405 here. For these two actions, register and users, validate and users. So on the users object, there seems to be a register operation. On the users object, there seems to be a validate operation. So we have effectively discovered two endpoints, and one of them is users register. The other one is users validate. How do we know that these two exist or not? Well, I can simply go fire up a curl, see if that comes up. Yep, it comes up with 405. Method not allowed. Okay, so maybe get is a method that's not allowed on that endpoint. So let me send a post request on that method. See what we get. This time we get a different problem that we're expecting JSON here. Okay, so let me also do this. I'll send the content type as application/JSON. Okay, and now we're getting different problems. It's telling us that I don't find a JSON object here. That's what it's telling us. So let me try and send data there. Let me try and send an empty JSON object, or maybe I'll just send a dummy JSON object there. Let's say foo. Nope, let me use single quote for this and double quote for JSON. Let me say foo bar. See if that does something. Okay, now we're getting progress. You see we're poking into the application. So this is what you're going to do in this exercise. I'm going to stop sharing again, start a 10-minute timer here, and putting this link to everyone. We'll do this again in 10 minutes. Okay, 10-minute timer. Okay, all right. So we're in our last 20 minutes, and there are two other labs that I want to highlight that are available here. One of them is an advanced insecure deserialization to remote code execution lab. Check that out as well. All these samples are borrowed from real-world assessments. So the techniques and the flow that you would see in these applications might still work in some of your applications. And this particular lab here tells you if you find an insecure deserialization vulnerability, how you could weaponize it to actually execute remote code, right? What we're going to do is I'm going to quickly jump into defense and show you how you could set up rate limiting as a prevention against some kinds of denial of service attacks, okay? So we're going to be using this open source tool called Kong API Gateway, right? This is open source. They also have a hosted commercial version available. They also have a GUI available. But we're going to be setting up Kong, right? And then we're going to be setting up rate limiting, right? We're going to be setting up rate limiting. When we set up Kong, our application will be proxied through Kong, right? We're not going to be calling the application URL directly. We're going to be calling our application URL via the Kong interface, right? And setting up rate limiting, we're going to experience how this goes. So in order to have this set up, almost all application gateways use this concept called services and routes. So that means if I have a bunch of services, I could define them as, okay, I'm going to call this as products. So that's going to be my services. I'm going to call reviews. That's going to be my services. I'm going to call orders. So that's going to be my services. And within these, I can actually say what's allowed. This is only get that's allowed. This is only get and put that is allowed. And with products, it's going to be get, put, post, delete, all of them. These are going to be allowed. I can define my services and I can also define my routes. I can change them as I want. So we're going to take a very, very simple example. I've already started this exercise. I'm in my first step. Sometimes there may be leftovers with Kong, so it's always good to start with clean slate. So I'm going to copy this command and paste it here. If it says not found, it's okay because this is precautionary. So those two commands are executed. Then what I'm going to do is I'm going to set up my first route for service with Kong, right? So this is a command. I'm calling the Kong API gateway. Remember I said we're going to have to set up services and routes. The first step is setting up Kong, and under Kong, the first step is setting up services. So we're setting up a service. That's why we're calling the service endpoint in Kong. You can also do the same thing with a GUI, but not very good for an automation perspective. So command lines are good for automation. So this is how you call the services endpoint and you create a new service called Concast API key. And then you say, this is the URL of the host. Okay, so that's what you do. So we'll set up the service. And then after we set up the service, we will have to set up a route. Okay, and we'll have to set up a route. And take a look at this route here. I'll also paste this command here. Take a look at this route. We're calling the routes in Kong, which means we're trying to create a route there. And then the name of the route is default route. Right? The name of the route is default route. And these are the methods that are allowed. Okay, so let me copy and paste this. So we have routes and we have services that are created in Kong. Okay, and this particular little API endpoint here requires an API key to authenticate. We're also going to be setting up rate limiting with API key. So one API key is going to be limited with 5 requests per minute. Okay, so with one API key, someone can only invoke our API 5 times in 1 minute. More than that's not allowed. If they want more, they'll have to wait for 1 minute. Okay, so that's the scenario that we're going to try here. So let's try and call our API endpoint. Notice that we're not calling our API endpoint here. We're going to call it via Kong. Okay, we're going to call it via Kong. So Kong is going to be our API gateway here. And it says 401 unauthorized. This is because it requires an API key, right? The direct URL for this is the direct URL for this is CASP. I'll also show this in production environments. What you will do is you will disable the direct route, right? You'll disable the direct route, which is this. All right, hold on one moment. This is probably a little different. CASP API v1 products. Okay, 404 not found. Okay, let me try that again. Okay, you get the same problem, 404 not found. Okay, let's ignore that for now. So this is the direct route. In real world, you will disable the direct route. And only allows services to be accessible via Kong, but we'll try and access via Kong directly, not worry about disabling the existing route for now, right? So this is Kong. Let's try and supply an API key here. So this is an API key. We'll try and call the URL with an API key. We get a bunch of products, right? So this works as expected. In the next step, what we have to do is set up rate limiting. Kong has this concept of plugins. Rate limiting is one plugin that is available, right? So how do you set up rate limiting plugin? So you call the rate limiting plugin, and then you say number of requests per minute is 4. This is a local policy. Limit by HTTP header, particularly the X API header. Okay, so that's how you set up header-based, API key-based rate limiting in Kong. So that is set up. So what I'm going to do is quickly use this API key and fire this 4 times. And that's 1, that's 2, and that's 3, and that's 4 within a minute, and that's 5 within a minute. So you have a problem now that says API rate limit exceeded. Now I'll have to wait a minute if I have to use this API key, or quickly if I want. So this API key ends with B2. There's also another API key that's provided here in the lab. Let me try this API key here. So this is D6, and this works, but the previous API key does not work. Like again, same thing with this API key. Second request, third request, fourth request, fifth request, you can already predict, right? API rate limit exceeded. So you could do this based on users, based on session IDs, based on JOT tokens, based on user IDs, based on IP address. You could do this many different ways. But here's an example of using Kong as an API gateway and using the features of an API gateway to provide rate limiting as a defense. So some of the contents that we present here were taken from the main API security course that we offer. And the reason we chose API gateway to be taught in the course is as you work with higher and bigger enterprises, they don't want to implement security controls per API. They want to implement it at an API gateway level, right? And that's why Kong, as an open source API gateway, is very integral as a part of this little mini workshop. Yeah, but Kong has many different plugins as well. In this exercise, we're looking at the rate limiting plugin. Let me start a 10-minute timer, and hopefully you could complete this as well. The last workshop of the day. But again, you have 5 more days from today to complete some of the other things that are available within the lab. All right. Okay, everybody. That's pretty much what I planned to deliver today. I'm a little bit glad that we're able to do this on time. If you want to spend more time on these labs, you have 5 more days that's available to you. Try and play around with the environment, with the API endpoints, with the same tools that are taught in the mini workshop or different tools that are taught in the labs. If you're interested, check out our other courses as well. With that, I'll leave it to Indrajit, the OWASP Singapore leader. Indrajit, over to you. Thank you for having us here.
Thank you, Maru. Thank you, everyone, for joining. I would like to thank everyone for joining. And also, I would like to thank our chapter leaders, Onchi and Cecil, for this session. Also, I would like to thank the whole team of Practical DevSecOps for bringing this session. It was really insightful. And also, the labs are really helpful. We can try hands-on after the session. Also, if you like the session, please feel free to share your reviews via LinkedIn. You can tag Practical DevSecOps. You can tag our AppSec this Singapore page, or you can even tag me. We plan to bring such workshops, every 1 to 2 months, so that the whole community can learn and also do hands-on labs. So we'll really look forward for your feedbacks on LinkedIn. Yeah, that's all from my side. Yeah, thank you.
Okay. All right, everybody. Thank you very much for your active participation today in the chat and during the workshop. So yeah, thank you very much, and have a good evening, morning, or day. And hopefully you learned something useful that you could apply at your world. All right. Okay. Thank you very much. See you later.